Welcome back to Math 103. This is video number 10 on fair division. We have already seen the divider-chooser method and how it works. We've seen that when two players are dividing contiguous goods between them, if they use the divider-chooser method, and if they actually follow the rules, then it will guarantee fair shares for both of the players, in our sense of fair share that we've been using in this chapter. Our next question is, how can we take the general approach and logic of the divider-chooser method and extend it to 3 or more players? We'll consider two ways of doing this. One is the lone divider method, the other is the lone chooser method. So the divider-chooser method has one divider and one chooser. The lone divider method is going to say, let's still have only one player who plays the role of divider, and all the rest are, in some sense, choosers. The other approach will be to have just one player who truly plays the role of chooser, and all the rest are doing some kind of dividing. So we'll see how these work. So first, the lone divider method. So instead of one divider and one chooser, there will be one divider and many choosers. This method is going to work for any number of players. And similarly to the divider-chooser method, it's going to start out randomly designating one player to play the role of divider. Okay, the rest we're going to call choosers. There are going to be 3 stages. Here's how they work. First, there's the division stage. Whichever player is randomly chosen to be the divider, that player goes and divides the goods into as many equally valuable shares as there are players. So if there are 3 players, that means there are going to be 3 equally valuable shares from the divider's point of view. If there are 7 players, then the divider divides into 7 equally valuable shares. 10 players, 10 equally valuable shares. After the divider has done this, each of the other players writes out a bid list. That means a list of which shares are fair shares to him or her. So think of this as a list of which shares are acceptable to that player. So each player produces their own bid list, their own list of fair shares for them. Then you get the distribution stage, and that's where the bid lists are all opened, and if there's a way to do it, each share goes to a player whose bid list contains that share. Okay, so everyone should get a share from among those the divider carved up. Everyone should get one share that is on their bid list. This is what we hope for. Now, sometimes it's not quite possible to pull this off. It doesn't quite work out that we can give each share to a player whose bid list contains it. We'll see what that means and how to resolve it. That situation is called a standoff. Okay? But the typical situation has the matter resolved at this 3rd stage right here. So let's look at an example. In fact, let's look at an example that we've actually already seen, though at the time we did not view it as the lone divider method. So we had this example earlier of Eve, Fred, Gail, and Hank, who are 4 siblings who inherit a large piece of land. And the land is not uniform, it has different features in different locations, and that meant that when the siblings wrote down their valuations of different parts of the land, they had very different opinions about it. Right? So a divider is chosen at random, that's what the method says. The divider divides the land into 4 parts, and we will call those 4 parts S1 through S4, for share 1, share 2, share 3, share 4. When the siblings go and write their assessments of the value of each share, they produce the following table, and in fact, we've actually seen these numbers before in an earlier video in this chapter. So now we're looking again at this example from the point of view of the lone divider method. So we can ask, who must have been the divider, and how can you tell? And also, what are the bid lists for each of the players? You've actually already done this in video number 6 in this chapter. Well, Fred must have been the divider, because only Fred values each share equally. No one else could possibly have been the divider, because if you look at other players' valuations, they don't value each share equally, which means that they would never have carved up the land in that particular way. So a useful way of picturing this is that there is some large plot of land, and Fred has gone through and put down those orange cones to mark the land off, and we're going to call these regions S1, S2, S3, and S4. According to Fred's conception, and this is why Fred put the orange cones down in just those locations, according to Fred's point of view, putting the orange cones in exactly those locations produces exactly equally valuable pieces of land to him. Okay. So he must have been the divider here. Only he is valuing each of these 4 pieces of land equally. As for the bid lists for each of the players, the reasoning process is something you've already gone through in an earlier video. The thought process, for example, was for Eve to find the total value of all the land from her point of view. That's $2 million. Therefore, a minimum fair share amount in dollars for her is $500,000. And then we go through and ask, well, which shares are worth at least that much to her? Thus, her bid list consists of S2, S3, S4, but not S1, which is not worth enough to her. The thought process is the same for the other players. Gail thinks that the entire plot of land is worth $1.2 million, so her minimum fair share amount is $300,000, and therefore it is only S3. There's no reason why it has to be more than one share that she considers a fair one. There will always be at least one. And that for her is only S3. That's the only share that she's willing to accept as a fair share. And for Hank, S2, S3, and S4 will all do. He'd rather have S3, of course, but S2 and S4 do meet his minimum fair share amount. Before going on to the next video, find a distribution of the shares to the siblings so that each one gets a fair share. Okay, this is, again, recalling something we did earlier, although at the time we didn't call it the lone divider method.